Good day, learners. In section 3, we have looked at how we are going to find the derivative of a function. Then we look at how to find the slope of a curve and its applications. And then we look at, maybe in other lectures, you have looked at differentiation, the meaning of differentiations, the first principle, the second principle. Now, today, we want to look at an example under section 4. We have looked at the theoretical aspect of this course. So we want to look at an example in study section 4, and that example is this, example 4.1. We have to find the slope of the curve given by y equals to s raised to the power 3 at the point P bracket 3,9. I told you that when you have this type of curve, there is a plus sign in the front of this, y equals to s raised to the power 2. So the nature of this curve is going to be a curve shape when you try to draw the curve. So the example, we have to find the slope of the curve given by this expression y equals to s to the power 2 at this point. I told you that when you have this type of function, the nature of the graph y equals s to the power 2, because there is a plus sign, because there is a plus sign in the front of this x, so the nature is going to be a curve shape. So we have y, x. So if you draw the graph, it's going to be a curve. It's going to be a curve shape. Then I told you the meaning of the slope or the gradient is an increment in y-axis all over the increment in x-axis. So if you look at this, you take a portion of this graph, join this one like this, join this one like this, join this one. So we have this along y-axis y2. Then this is the lower, this is the upper limit. This is the lower limit. Then the upper limit of x along the x-axis is s2. Then along the x-axis to the lower limit is equals to x1. So the slope is going to be increase in y-axis all over the increase in x-axis. So we have slope equals to y2 minus y1 all over s2 minus x1. Now let's look at the solution of this example. We put f of s equals to s to the power 2 because y is the same thing as y equals s to the power 2 is the same thing as saying f of s equals to s to the power 2. Then we have to find the slope. So the slope equals to limit h is tending to even. H is a very small number. H into f into 3 plus h, where our x is now this, is 3 plus h, minus f of 3. So that we have when our s equals 3, when our s equals 3 plus h. Then limit h is tending to 0, 3 plus h raised to power 2, because we have this function as raised to power 2, minus 3 raised to power 2 over h. Then we are going to expand this, 3 plus h into 3 plus h. So if you multiply, if you open the bracket now, that will be 3 times 3, 9, plus 3 times 8, plus 3h. Then h times 3, that will be plus 3h. Then h times h raised to power 2. So we have 9 plus 6h plus h raised to power 2. So we have this. Then f of 3 is 3 raised to power, is 3 raised to power 2, which is equal to 9. So if you open the bracket, all over h, we have this. Then minus 9, this now will cancel. So we have limit h is tending to 0, 6h plus h to the power 2 over h. Then so far h is common. We have h. This is the numerator, denominator. In the numerator, we have 6h plus h to the power 2 over h. H is common. We take one h out. If you take that h out, we now have limit h is tending to 0, bracket 6 plus h. Then the condition is that h is a very small number, and that h is tending to 0. So when anywhere we see h now, we say h is equal to 0. 6 plus 0 is equal to 6. That is for that example. Any question? I hope you understand. Because when you look at this, but we are given these 2 points. These 2 points along, we are asked to find the slope of this curve. So what we have done is that the first value is x1, this one is y1. So we have this as the solution to the limit of that function. I mean, to the slope of that function. The slope is an increment in y-axis all over the increment in x-axis. That is for example 4.1. Then example 4.4, we have another function where we have f of x equals to x to the power 3. We have to find f the prime of x. That is the first derivative. F prime of x, that is the y dx. F double prime of x, that is the 2y over the s2. And so on like that. So instead of saying f the prime of x, we can say that this is the y over the x, the y dx. Now, by definition, when you want to divide differentiation of a function is an increment in a given function. So by definition, f the prime of x, this is the definition of differentiation. Limit h is tending to 0, f bracket s plus h minus f of s over h. This is the definition. The original function minus the new function, the increment in that function over h. Then we have limit as h is tending to 0. Our h now is a small increment, s plus h then raised to power 3 because the function is a polynomial function. Minus s to the power 3 over h. Then when you now open the bracket here, that will give us limit h is tending to 0, bracket s to the power 3. When you open the bracket, s plus h into two places. S to the power 3 plus 3s to the power 2h plus 3s plus 3s h to the power 2 minus s to the power 3. When you open the bracket, this one will cancel this. Minus and plus sign over h. Then limit h is tending to 0. So when you now look at it, h is now, because this one has gone, we have 3s squared h plus 3s h squared. H is here, h here, h here. Numerator, we have h there. Then denominator, so we have to divide 2 by h. When you divide 2 by h, then we have this expression done as h is tending to 0. So when you now put h to be equal to 0, 3x times 0, h is 0, then 3s raised to the power 2 plus 0 plus 0. That will be 3s raised to the power 2. And that is f prime of x, which is the same thing as the y dx. So if you can continue, you can still find the derivative, the second derivative of this function. You can still say f double prime of x, which is the 2y dx square. You can continue like that. And that is just an example. There is the same as the slope. The derivative of a function is the slope of that function. So it's the same thing as finding the slope of that function, which is the y dx. Any question? So you have to do your assignment, do your classwork, then you go over your note, the one we have done before, look at it very well. Look for materials, and then if there's any question, you can see me. Thank you.